What variable are we going to eliminate? X's. You choose X's. So what do you want to do first? Top. 2x minus y minus z equals 15. And you said bottom. But first, multiply by 2. Negative 2x minus 8y plus 6z equals negative 40. Excellent. I love how you did that so fast. That was amazing. Negative 9y plus 5z equals negative 25. We good? Now what? We need another equation with y and z because we have 1, so I need 2, right? So we're going to eliminate x again, okay? So do you want to use top and middle or middle and bottom? Top and middle, okay. 4x plus 5y plus 2z equals 10. I just rewrote that right there. Let's multiply the top by negative 2, and then we'll write it right there. So negative 4x plus 2y plus 2z equals negative 30. Yes? What do I get here? 7y, 4z, negative 20. Okay. Now I have a system with 2 variables and 2 equations. So I start over, right? Okay. So now I want to eliminate either y or z using this system right here. Which do you choose? Z is probably the best choice. Okay. The numbers are smaller, right? Why would some people choose y? Because they're already opposite signs, right? Do you see why some people would choose y? You guys chose z, though, so I'm going to go with z. Okay? What are we going to need to multiply this equation by? 4. And what are we going to need to multiply this equation by? Negative 5. So negative 36y plus 20z equals negative 100. Whoops. Sorry. I'm going to write this one right here. Negative 35y minus 20z equals 100. Combine them. So negative 71y equals 0. What do you think the most popular reaction is at this point? Panic. Yes. Why? Because you got a 0, right? Are answers allowed to be 0? Yeah. You can check back with your work if you want, especially check signs, but it's not necessarily a bad thing for you to get 0 as your answer. Doesn't it usually make things easier? Mm-hmm. So I know why. What do I do with it? Where would you like to plug it in? So here, okay, 7 times 0 plus 4z equals negative 20. So that's pretty much just like not there. That's 0, right? So I can just divide both sides by 4. Z equals negative 5. So I know y and I know z. Now I got to go back and plug it in to find x, right? To where? Oh, the very beginning. You want top? Okay. 2x minus 0 minus negative 5 equals 15. So subtract 5 from both sides. 2x equals 10. X equals 5. So my solution is yeah, it was on the homework. Yeah, that's why I chose it. Okay. some people were struggling with this morning with it, so I decided to use it to our advantage. Okay? This is typically the time in this chapter when, quite frankly, you hate me. And I accept that. Because I already knew what the answer was, because the calculator told me. Five, 0, -5. Yeah, I'm getting lots of dagger eyes right now. Remember, I'm your math teacher. I have to teach you the math. After you've proved to me that you know the math, and I know a calculator trick, I promise I'll teach it to you. Okay? You just proved to me that you can do the math. Can I show you how to use the calculator now? Okay? Right now? Okay, yes, ma'am. Yes, ma'am. Wrong way. 2x minus y minus z equals 15. Yes, this is exactly the same question we just did. Okay? Because we already know the answer. The answer is not the important part at this point. It's the process. Yes, I would like you to write it down, please. 4x plus 5y plus 2z equals 10. Because there's still work to show if we're using the calculator, and I want to make sure that you understand what I expect to see for work when you use the calculator. Is that fair? Okay. So here's the system we're going to use. Before we can even use the calculator, I need to write my coefficient matrix. We're going to write a matrix. Now, we're not writing the matrix. That's someone else's job. Neo or somebody. Okay? We're writing a matrix. A matrix is a rectangular array of numbers. Do you guys even know what I'm talking about when I say the matrix? You guys suck. It's a movie. There's 3 of them, and there's about to be a 4th one. And I love them. I think they're awesome. Keanu Reeves, what more do you need? Okay. I'm going to write the first row of the coefficient matrix. You tell me where it came from. Yeah, it's literally called a coefficient matrix for a reason, right? It's just the coefficients from the equations, right? So what's the second row of the coefficient matrix? And 10, good. And the last row? Okay. Now we go to the calculator. In Spanish, calculadora. Very first thing we do is turn our calculator on. That's a very important step. Okay? We want a new document. No, we don't want to save our old one. Okay, here's the deal. I'm going to have to zoom in on my calculator like this so that you can actually kind of see what's on my screen. I hit menu. Home. New document. No, you don't want to save your old one. Did you turn your calculator on? Okay, good. That's a good start. So are we together now? We want a calculator page. Okay? So we want a calculator. Oh, now you're going to focus? Awesome. Are you there? Okay, good. So, first things first. Menu. Any ideas? Yeah, look at 7. Matrix. Okay? Now, we need to do some steps a little out of order. Well, they're not out of order for the calculator. They're a little out of order for us. So I need us to choose reduced row echelon form, which is number 5, without you knowing what that means yet. Okay? It'll save us some time in a minute. So choose number 5, reduced row echelon form, and then go back to menu and back to matrix so that we can actually create our matrix. So you see create, number 1, and you see matrix, number 1. So it's asking us how many rows and columns we have. Okay? How many rows does my matrix have? 3 rows, tab. If you try to use the down arrows, it's going to mess up. So just use tab. How many columns are there in my matrix? 4 columns. Everybody with me? Okay. I hate that it won't let me clearly show you the calculator. Can you see that I have 3 and 4? Kind of ish. Then press enter. What should be there should look like the one we just drew on our paper. Right? So that's how you're going to, really easy way to know if you messed up, if it looks different. Okay? Like if you get your 3 and 4 mixed up, it'll actually be that wide and it'll have one more row down here. That doesn't look like what we have, so make sure it looks like what we have. Okay? Then we just need to enter, excuse me, our coefficient matrix into the calculator. I will advise you again to use the tab button instead of the arrow button, only because I think it makes it easier. Because when I get to the end of the first row and I hit tab, do you see that it takes me right to the beginning of the second row instead of having an arrow everywhere? Okay, so put all of your numbers in, and before, like once you get all your numbers in, do not hit enter. Not yet, please. Oh, dang. So are you here? Are you right here with me? Is everybody else with me right here? Just watch, okay? Is everybody right here with me? I haven't hit enter yet on purpose because I want to take the couple seconds that it will take, literally the couple seconds, to compare with what I have written on my paper to what I actually entered in my calculator. How easy is it to miss a negative sign here? How easy is it to enter a 5 instead of a 6 here? Very. How much time is it going to take to go back and enter everything correct? A lot, right? So take the time real quick to check and make sure what you wrote down on your paper is what you actually entered into your calculator. I think mine's good, so I'm going to press enter. Okay? So this is the matrix that comes up on my calculator now. 1, 0, 0, 5, 0, 1, 0, 0, and 0, 0, 1, negative 5. Okay, all I did is hit enter. That's all I did. Okay, so this was where I started. This was my coefficient matrix. This is my answer matrix. Got it? Now, I need to take my answer matrix and convert it back into equations. Remember I took equations and moved it to a matrix? What if I moved this back to equations? What does it look like? 1x equals 5. Y equals 0. Z equals negative 5. 5, 0, negative 5. Does that make sense? Now, this only works under certain conditions. Does everybody understand that? This only works if these numbers right here are a diagonal of 1s. Why does that matter? Exactly. It's saying 1x, 1y, and 1z. This triangle right here and this triangle right here has to be zeros, right? Because 0y and 0z, 0x and 0z, 0x and 0y, right? That's the only way this works. Guys, this, when it has a diagonal of 1s and 2 triangles of 0s, this is reduced row echelon form. Okay? If you just choose row echelon form, this triangle will be 0s. This will probably be 1s. This isn't going to be 0s, which means this is not your answer. Okay? So make sure you choose reduced row echelon form. This right here is reduced row echelon form because it has a diagonal of 1s and 2 triangles of 0s. Does that make sense? When it's in reduced row echelon form, this is almost always your solution. So how will you know when it's one of those times where it's not your solution? Can I show you? Are you unmad at me now? Not yet? Okay, awesome. Example number 1. 1, 0, 0, 4, 0, 1, 0, 5, 0, 0, 0, 6. And example number 2, 1, 0, 0, 8, 0, 1, 0, 9, 0, 0, 0, 0. These are my 2 examples. Okay? Do I have a diagonal of 1s? No, I do not. If I look here and don't see a diagonal of 1s, I know something's wonky. Okay? When that happens, I need to look straight to the last row. The last row is going to tell me what's going on. Okay? Please convert the last row for me back into an equation. 0 equals 6. Does 0 equal 6? Will 0 ever equal 6? Then that is correct. No solution. Do you see the difference? I don't have a diagonal of 1, so I've got to look at the last row. If I convert the last row back into an equation, it is something that is not true. But look at this last row. I don't have a diagonal of 1, so I look directly at the last row. 0 equals 0. Doesn't 0 equal 0? Infinitely many solutions. It's the last row. Look at the last row. Convert it back into an equation. 0x plus 0y plus 0z, that's just 0, equals 6. Okay? Now I will tell you this. I'm going to go back up to my coefficient matrix for this problem that we did. Sometimes when you see these matrices written, we have a vertical line here. We have a vertical line here. Why do you think we might put a vertical line there? What is that signifying? The equal signs. Okay? And if we ever get into a situation where we need to talk about augmented matrices, this is an augmented matrix because it's got that line in there. And we can do different things with augmented matrices. Okay? So I would like you to get into a habit of just putting a vertical line right there. It will help you. It will give you a visual clue where that equal sign should be. Because think about the beginning of this week when I told you how important it was to line up your x's, line up your y's, line up your equals, line up your constants. Remember I made a really huge point about that? This is why. If you try to put these in and they're not x's, y's, z's, equals constants, you're going to get the wrong answer every time. You cannot put them in the calculator without them being lined up like this. This vertical line will give you a clue of where the equal sign should be. Yes? It's a visual reminder. Okay? Any questions about that? So what do I expect as far as work goes? I expect the problem. I expect the coefficient matrix. I expect the answer matrix, and I expect the answer. Can you go from the answer matrix to the ordered triple without writing this? Yeah, some of you can. Okay, if you can, you have permission to. If you need to write this down, then write it down. Okay? But when I'm looking for work, I want this, 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 and this right here. This is not necessary if you can go from here to here. Got it?